coming. This is my talk, eSIM management on Qualcomm phones, which kind of covers what I've been doing over the past couple of months and what I've learned and what I want to share with you. So about me, my name is Luca Weiss. I work on several projects in my free time, such as PostmarketOS, Linux kernel contributions, OpenRacer project. At my day job, I'm Android platform engineer at Fairphone, so everything was a bit inspired by Fairphone, and also most of it was done in my work time, which is pretty cool. You can find me on Mastodon if you want. We did some cool stuff yesterday with some smart clocks and mainline Linux and hacking it. Anyways, other topic of the talk, eSIM. We'll talk a bit about what is eSIM in general, cover a bit like removable eSIMs, LPAs, etc. Go about the Qualcomm modem basics so we can understand how eSIM management works on Qualcomm. So we're going to be talking about QMI and QRTR. Then about the open source implementations of the LPA, so the thing that runs on the phone. And then about actually also the UI that I've written for on top of it. Just to be clear, there will be simplifications. I'm also still learning. There will probably be mistakes, and probably Harald will know much better because he he works on this. But yeah, I hope you learn things about this, and it's quite useful. And yeah, telephony in general is very complicated, so yeah, that's why I want to add this. A colleague of mine didn't laugh about this joke or this meme in the corner. Yeah, but yeah. So yeah, eSIM and eUSSC. So eSIM is the abbreviation for Embedded Subscriber Identity Module. So the embedded version of a SIM card that you put in your phone. The eUSSC is the embedded version of the USSC that you sort of put in your phone, which is the Embedded Universal Integrated Circuit Card. And so kind of eSIM is, as far as I understand it, kind of the term is the software that's running on a eUSSC chip that is actually soldered to the PCB traditionally. Yeah. Also, normally you're used to getting a SIM card from your operator. You buy them in the mail or you get it in the store, and then you put it into the phone, and then it works. With eSIM, actually, no physical card at all is required. You can just download essentially the same information that's on the card onto a chip in your phone instead. And after you've downloaded it and enabled it, it works exactly the same way. Yeah, so this eSIM was first, it seemed to be, it was first used in smartwatches, where I think the main point was that there's not really any space for even putting a nano SIM slot in there, and also making sure that it's waterproof and everything after that. But it also was very quickly adopted into smartphones and tablets. And also nowadays, laptops with modems have eSIM built in, and yeah, a bunch of other stuff too. So I'm also here talking, this talk is about the consumer eUSSC, which is the SGP22, and not the M2M eUSSC, which is SGP02, or the IoT eUSSC SGP32, which are apparently completely different. And so this is only about the consumer eUSSC, which you will only ever touch, or which is the only thing you will touch as a consumer, I guess, unless you're doing like really weird stuff with other things. So yeah, like basically all components inside the whole eSIM architecture, let's say, so like the different servers and the different components, they're all certified by the GSMA to make sure that they actually, that they're actually secure and they cover the requirements. One major exception is the local profile system, which is essentially, let's say, it's a proxy between the server components and the eUSSC chip, which are both secured. So there's not really too much to do there, and I think this was also kind of meant for simply just managing eSIMs, because it's just enabling them, disabling them, deleting them. So this is all kind of easy operations. This also means you can't put non-certified profiles on your commercial eSIM, like ones that you, for example, write yourself and try to do something there, because then the eSIM that you have on your phone, for example, will be GSMA certified, will only accept GSMA certified profiles. And the other way around is the same. You can't put a certified profile on your homegrown eSIM, like if you make your own implementation of this or something, like your own chip. This is for a normal consumer, it doesn't matter because they are not trying to hack around with their eSIMs. But for example, some camps, so like the Tor camp, they have the Shady Tag network where they just hand out SIM cards that they make themselves. And then you can put it in your normal commercial phone and they do work correctly. And yeah, because there's no authentication, like there's no authentication from your phone that the SIM card you put in is like certified for someone, you can just use it. And if the keys allow you to get into some network, then it does it. I guess for like these operations, yeah, either they might be able to pay some money to a GSMA authorized profile authority, let's say like that, which will cost some money for them, but yeah, that's it. Removable eSIM. I was just talking about the eSIM that's actually sorted on the PCB, but there's nothing special about this that you can't put like in a plastic form factor. Like you can just, like nano-SIM form factor, you can put in your phone, and then you have essentially the same chip just running on in a different form factor in your phone. It's like the 4FF form factor is nano-SIM, and the or normal size SIM card or micro SIM, I think it was called. Yeah, management works exactly the same. It's like it works the same as in technically on an Android phone, for example, or I think it's even worse on iOS, but on Android, the OS configuration hardcodes which slot is actually an eSIM, and then the proprietary management tools like the Google local profile system that we'll talk about later. It will use this slot to actually then manage the eSIM and do all these operations like download it, enable it, disable it, delete it, whatever you want with it. The way that commercial ones, which also includes the Sysmocom card and the 5-bar card, and like eSIM.me. I think there's maybe some other vendors of this. For Android, you can actually put a special field on the SIM card, like on the physical card, that tells Android to allow a specific app to talk with the SIM card using kind of an authorized channel, which is using the OMAP, Open Mobile API, which can be used to access the secure element in the SIM card. So yeah, talk with the SIM card and run these APDUs, so the communication between the phone and the SIM card. And using this, then they can do the same operation, so download the SIM card, enable it, disable it, etc. On iOS, there's no support for removable eSIM management, as far as I know. There's one, actually from the 5-bar company. Apparently, they recently released a product which you can sort of use on iOS. You can switch between different profiles, so disable one, enable a different one. But actually, for downloading the eSIM, you put the same SIM card into an Android device, download it there, and then you can put it back into an iOS device and then switch between the different ones there.
It also works for eSIM.me. So once
Also eSIM.me also works on iOS like this?
Once you put the profile on an Android phone, it works in iOS.
Ah, okay. Okay. Yeah, so. Okay, so on eSIM.me you can do the same on iOS apparently. But yeah, so it's super limited on iOS. I mean, there's no technical reason why it should be that limited. They could just allow it essentially and do a similar like authorization like the RRM on iOS, but yeah, maybe at some point. Okay, local profile assistant. I've talked about the LPA term. I mentioned it a few times. So this is essentially the software which runs on in telephony speak UE, the user equipment, which is just the phone in your case, or in a different case, it's the laptop or the smartwatch or whatever. This LPA is the component responsible for talking to the SMDP Plus, which is the Subscription Manager Data Preparation Plus. There's always amazing different terms in the GSMA world. But yeah, essentially, it's just making an HTTPS connection to this server, and and getting the data, basically sending the request to it and getting the data back. On the other hand, kind of into the phone, it is interfacing with the EURCC via these APDU commands. So this is just essentially passing some data back and forth. The APA is basically the component that's responsible for managing the eSIM profiles, so enabling it, disabling it, deleting it, what I said, downloading the new eSIM profiles from the SMDP+, and then also from the other side, like from the SIM card, it can actually create some notifications, as they call them, which it will do, like if it has successfully installed the profile that you've downloaded. It will actually create a notification about this install event, and it was successful. And then the APA, like the local assistant, basically the app, is then supposed to send this to the server so that the server also knows that the eSIM has been, like that the profile has been installed successfully. There's also notifications for enabling a profile and disabling it. I'm guessing also for delete, but I haven't really deleted profiles myself yet. On Android, like on a stock Android phone you will probably be running the proprietary Google local profile assistant, which is included in the GMS bundle, so the Google Mobile Services. That's the package ID that's there. You can also look it up in the Play Store. I think there's called SIM Manager or something. I think some other, like it's not mandatory to have the Google version of this local profile assistant on an Android phone. Some vendors, I think, also have their own implementation of it. On iOS and Windows and everywhere else you have an eSIM card, you will also have some sort of local profile assistant that will be able to do these operations. eSIM in Linux mobile space. This is a bit about kind of, let's say, until a few months ago, what you could do properly. So what you could do is, for example, I give the example here Ubuntu Touch because it's quite it doesn't have a local profile assistant included, but you still can do telephony quite well there. So to actually, to use an eSIM, you could actually basically on Android, so either flash Android back, you can install the eSIM, which then puts it on the chip in the phone, and then enable it, so then actually shows up as a normal SIM card essentially, and then reboot back into Ubuntu Touch or flash Ubuntu Touch back, and then actually you have this, from a modem perspective, just a normal SIM card that's there. Of course, then in Ubuntu Touch you can't enable or disable it or do anything other than just using the SIM card. This way you could use an eSIM card even without having any of this management functionality implemented. What's also written here? Once the eSIM is configured, it's essentially just a SIM card for all intents and purposes. So it shows up as a SIM card. It smells like a SIM card. It looks like a SIM card. It is a SIM card, just kind of sort of virtualized on the chip. Let's say like that. And also, I don't think there's been any open source implementation of a local profile assistant until recently. There's a project called LPAC, which seems to be getting worked on, and it works quite well. The initial commit of this was only in late 2023. And before that, I don't think there was any implementation. This LPAC project only had a PCSC interface, which is used for smart card readers, so you can put the SIM card in a smart card. Like on a PCB, like on an eSIM on a PCB, you wouldn't be able to do directly that. In theory, you could desolder it, put it into an adapter, and plug it into the card reader. If you had something that basically routes the pins correctly. And it also has an AT interface. This might be useful on some modem, like on some external USB modems that you put in. But also some of those actually require different management interfaces, which I'll come into later. Yes. Okay, so before talking about how the eSIM itself is managed on or can be managed on Qualcomm, or the way to manage it on Qualcomm, I I want to explain a few of the, let's say, basics for modem communication on Qualcomm, because it is quite a different way to do things compared to, let's say, desktop Linux. So there's a thing called QRTR, which is also sort of known as QIPC RTR, which is the Qualcomm IPC router. So it's actually a sort of network protocol, which in the Linux kernel you can find on AF_QIPC RTR. It's kind of a socket type. So instead of doing a TCP socket, you make a QRTR socket. As transport it is using a thing in Qualcomm called shared memory device, where it can then basically talk to the modem using this. QRTR can also run over, for example, MHI, which is a different protocol, which I think is used for PCI attached modems or something. So there you can still use the same, or Qualcomm can still use the same networking protocol, just over different transports there. QRTR itself, you can kind of think of it like UDP. It probably is not. It's probably quite different to UDP, but essentially, you, instead of having a IPv4 address that you connect to with the socket and a port number, you actually just have a single node number and a port. This node, for example, is it is basically one of the different processors on the SoC. Because in Qualcomm SoCs, and I think most other SoCs, there's a bunch of different processors running with different firmware, which do different tasks. So if you run on a Qualcomm phone, the command QRTR lookup, you see a long list of services basically, which have the numbers service, version, instance, node, and port. The first three of which are actually not really directly a thing for this networking protocol, but it's actually just sort of a name server, so the QRTR name server, where services register and then gets discoverable using that. So there's a service number, which is just identifying a service. For example, the number of 4097 is a DIOC service, so for diagnostic purposes. There's a version number, which is sometimes used for versioning things. It doesn't seem to be used very consistently. In theory, a service should be able to run with two different versions, so that a migration over the services can be possible more easily. But in practice, I don't think this is used really much. There's also an instance number where the same service can run multiple times for different reasons. I'm not too familiar there. But yeah, basically, if you want to speak to a given service, you actually go to the name server. You ask it, hey, I want to talk with service number 11, and then you can get a list of the services that are running as service 11, or let's say the services as running as service 11, and then you can figure out like which node and which port it is running on. And once you have this information, you can actually then open your socket to the given node, so let's say compared to the IPv4 address, and the port, which is basically a port number here. So the combination of node and port is unique, let's say, in a running system. But I think they are sort of allocated at runtime, so they're not fixed port numbers over time. Yes, I also, a side note, on older Qualcomm phones, for example, Snapdragon 801, you can also use QMI, which I'll cover in the next slide, over a different transport, so kind of directly over SMD channels, so similar to how QRTR is running over in phone cases. But actually, there it's sort of skipping the network layer, and it's using a slightly different way to do it. But yeah, let's say in the last, I think 8 years ago or something, Qualcomm started using mostly QRTR for their services. Okay, QMI. This is also like QRTR, like it's both sort of network protocol, and then you have a name server behind it. QMI is both basically a way to encode binary structured data into a binary stream. but also it is sort of the collection of interfaces which are specific to Qualcomm devices, or like Qualcomm-made devices, which also includes brands like Quectel and Foxconn modems and whatever, which all use Qualcomm in the back, let's say. Yeah, for let's say the first point, so like it's just a way to encode data into binary. It's using a type length value, a TLV encoding, which essentially just which is a sort of relatively flexible way to encode this data. So there's like a fixed number of bytes which define the type which is coming, then a length, like a few bits or a few bytes that specify the length of the whole message, and then just some value that this message contains. All of these messages in QMI, they are requested by the client, and then you will get a response by the server back. It only works one way in this sense, but there's also these indications which are basically used for notification. So if there's something important or something that the modem, for example, wants to tell you, it can send an indication for a specific interface, and then you can handle this. And for example, I don't know, if the modem says, the network strength has changed, then Android can know that the network strength has changed. For the second part, it's kind of a collection of defined interfaces, QMI. So there's a bunch of functions which are grouped into services. So for example, there's the UAM service, the user identity module service. There's like, I don't know, like at least 30 different services which do different things. So for example, there's a service which is 0xP, and then there's a huge list of calls which can do everything like related to user identity management. So for example, this includes anything with SIM pin cards and a lot of other things. So for example, here calls number 0x28 is change pin, and then as input parameters this call, which is statically defined essentially, like it's an interface. You provide the old pin from the SIM card and the new pin you want to change it to, plus a few other things, and then as an output you get the result, so whether the change was successful, and you also get a few other things back. So if it wasn't successful, you get back how many tries you have left, and things like this. If you're interested, there's a long list of these interfaces in the libqmi repository, which is an open source project on gitlab.freedesktop.org, and they're in JSON format. They have a bunch of these calls defined. It is far from complete as far as I understand it. There's also a lot of calls which exist in the world which are not implemented in there, either because somebody hasn't used it yet, or or just hasn't been implemented yet. There's also other user space implementations for QMI. There's, for example, I think uQMI it's called, or QMISC is a different one that can convert different. So instead of libqmi generates from this JSON, it generates some C interfaces that you can use in your programs. But there's different formats which doesn't come from JSON. But libqmi is a nice glib-based library for doing this. Okay, so now that we know what QRTR, so networking protocol, and QMI, the way to put data over QRTR for this sense, we can talk about how to actually put this together and then manage eSIMs on Qualcomm devices. Basically in this LPSC project, which is this open source local profile assistant implementation, any driver, driver, they call it driver, it's sort of a backend. So they also have they have the AT backend, the PCSC backend. So each of these backends needs an operation for opening a logical channel to the SIM card. So to be able to talk to this eSIM application on the SIM card. Then send some binary data to it and receive the response back. And then also close the logical channel again. All these APDUs, they're not specific to Qualcomm. They're just a generic thing. And also so the backend in LPSC doesn't need to care about this. Just get a bunch of binary, you pass it to the SIM card, you get a response back, and you pass it back to the LPSC program. and then it can do, it can parse that and use it as necessary. So all of these three cars, they are just let's say, simple encoded message using QMI, and we send this over QRTR socket to the modem, to this user identity module. So for example, the open logical channel call, it's 0x42. It has some parameter, which is the AID, the application ID, I think, which from LPSC side is always a fixed string, which is the ID of this eSIM management application on the SIM card. And then this QMI call returns back the channel ID, which you can then use for the next call, which is send APTU, which has ID 0x3b. It takes in the channel ID, which we just got, and the APTU contents as a string, or like as a stream, let's say. And then as a return value from the modem, we get back the response from in the APTU format. And then this last operation, close logical channel, 0x3f, and we just give it the channel ID as parameter. And then the modem closes the channel again, because you can only open, at least on Qualcomm, you can only open a logical channel to a specific application once. And so you always need to close it again if you want to open it again. In theory, you can send multiple APTU. You can send APTU multiple times with the same channel ID, but in practice, the APSC driver seems to always open, send, close, and then for the next call, they do the same thing again. Yes. So for these QMI calls, because without having any source code for this, you won't know like which format these QMI calls are in. So like open logical channel, send APTU, and close logical channel. But fortunately, already Chromium OS has an open source or at least reasonably open source implementation of a local profile assistant, and they have actually already implemented at least 2 of these 3 operations in there. So I was just able to take the format from there and basically transform it into the format that libqmi wants in their JSON format, and then implement it there. The third call I was able to find in a weird source dump called Gobi API, which is, I think it's like from 2012 or 2013. It was used for some Qualcomm external modem things back then, I believe. Okay, so with these 3 calls implemented in libqmi, it was time to make the first proof of concept to connect LPSC, so this open source project, with the Qualcomm modem. So with libqmi, they also have a command line tool called QMI CLI, which is basically just a CLI client for sending QMI calls. And fortunately, this LPSC project has a STDIO backend, which just prints the request that it wants to send to the modem in JSON format to STD out, and back in, it just expects the responses in JSON format back on STD in. And this was really useful actually for developing or just trying it out first time, because I had no clue if this was actually going to work. So just wrote a simple Python wrapper around this, just reading the lines that LPSC prints out, and then parsing it, getting the required bits, calling QMI CLI, with the correct ARM parameters, so like in Python, just subprocess.checkoutput, hacking up the output again to put it back into correct JSON format, feed it back into LPSC, and then, okay, after some bug fixing, it just worked. Like all the operations worked because, fortunately, it's for the LPSC or for the backend, like just these 3 operations were necessary. And once these 3 were working, like all the different calls, like listing the profiles, enabling profiles, even downloading the profiles, then basically just worked, which was really nice. Of course, having a Python wrapper script around an STDIO driver in this project is not the best thing. I put it on my GitHub for, just to have it there. Actually, somebody else took this and kind of changed the QRTR bits, which are used for Qualcomm phones, and replaced it with MBIM, which is some Windows networking thing, or a different way to communicate. And then they changed just basically QMI CLI to MBIM CLI, where these calls were like open logical channel, etc., were already implemented. And then that one sort of got a bit more steam, and quite a few people seem to be happy to use that because they weren't able to manage eSIMs on these like external, I think, USB modems. So there's some Foxconn external modems, like some Quectel ones. Apparently some people have. Honestly, I haven't used a LTE stick in like, I don't know how many years. While it does work, it's of course better to have something integrated in LPSC directly, so you don't have to worry about like weird wrapper scripts and parsing output in Python. And so the implementation in LPSC, so libqmi, this is a glib-based project, and they provide the API over basically glib async. So you send a request to it, and you provide a callback, and then libqmi calls the callback with like the glib main loop. This didn't really work inside LPSC API because that's just a synchronous API. So the LPSC core just expects to call one function, open logical channel, and in the same function get as a return value the logical channel. And also there's no glib at all in this in LPSC. So it wasn't super easy to get it in there. But fortunately, I wasn't the first person in the world to kind of try to push this async API into a synchronous context again. It took me also a while because there's a few different approaches apparently that you can take, and it didn't really work in the first time. But after a while, fortunately, I could get that to work, and it wasn't hanging anymore. So then essentially, I just implemented the same functionality that I had in the wrapper script. So doing the 3 calls over libqmi directly in C code, and that also started working then. And since LPSC version 2.0.2, this QMI over QRTR backend is merged, and it should work on anything from Qualcomm phones to probably Qualcomm smartwatches that have eSIM integrated, and Qualcomm tablets, and anything else that Qualcomm makes in this form factor, maybe TVs, I don't know. They shouldn't have eSIMs, hopefully. Then somebody else took my code, including this wonderful pushing async into a synchronous context, and made a QMI over, or just a QMI backend, which is more or less going over a node in /dev in Linux. So not over QRTR, but over just /dev as a device in /dev. And this was also merged. It was made by Robert Marco. And this is used apparently for example, this Quectel RM520N modem. For this MBIM wrapper that I was talking before, this is still missing a proper implementation in LPSC directly to not use this wrapper script anymore. It shouldn't be too tricky to make because libmbim is also using the same glib async stuff. So you just need to make a few, let's say, synchronous wrappers over the async API, or you can just copy paste it. And then it should also work on some other modems, which includes, for example, this PCI attached modem, which is some Foxconn modem. There's also an interesting table in this LPSC MBIM wrapper repository, which goes over like, I don't know, 6 or 7 different modems. Because apparently some of these modems you can control in multiple ways, at least in limited ways. So you can talk with them over AT commands, you can talk with them directly over QMI, you can talk with them over MBIM, and like it's a bit of a random mix, like on which modems which one works exactly. So it's going to be fun for the people that put this into like laptop distributions, but to my eSIM Manager app. So because LPSC is just a command line utility, and even though I think we all like command line utilities. Some people might also prefer a GUI on top of this. And since the only GUIs that were so far available for LPSC was first of all a Java-based GUI, which looked very much like it was made for desktop. I didn't try it on the phone, but I'm pretty sure it wouldn't have scaled down correctly. And there's actually also a version for like an LPSC wrapper for Android, which is called OpenEUSCC, which you can install either via Magisk, for example, as to have a system module, or you can install it as a user app. And then what I said some slides earlier with these RRM keys on the SIM card, you can actually then authorize the app to talk with the SIM card. But yeah, for Linux Mobile there was nothing. So then I started writing my eSIM Manager app in GTK4 and libadwaita, to provide a graphical way to manage eSIMs on Linux Mobile specifically. So it is also just a GUI for LPSC. It doesn't really do anything special. It just calls LPSC in the background whenever you do something and makes a nice list from the output that LPSC gives me. It is definitely quite basic, but it is functional. So you can, as I said, all the normal operations that we need, add SIM card, like download a SIM card, enable it, disable it, delete it. It also has support for multiple SIM slots. So depending on which SIM slots, you have the eSIM either sorted on the PCB or just you put it on a plastic card into your phone. You can switch between them, and this works quite well. But there's also definitely some missing features in the app. For example, these notifications I was talking about. So the eSIM wanting to tell the backend server that something was happening. This is not handled yet. I was actually working on this on Friday on my way here, but it's not finished yet. There's definitely some design improvements that you can do. It doesn't look too bad, but in my eyes, you can see that it was made by a programmer because I'm not a designer. So if you have an eye for design or you know someone with an eye for design, please let them look at it and tell me what to make better, or even send a pull request. Also, it doesn't have a logo yet, so if anybody designs a logo, please. So LPSC itself, it has a pretty nice dummy backend. So instead of actually calling LPSC, there's a backend that's just pretending to call anything. So this you can use quite well to just develop this on your laptop and run it on your laptop, and then only after that, actually make sure it works with also the correct LPSC backend. This was basically the whole way I was I was developing it. It also scales a bit, if you run it on a laptop. I also have a demo here where you can see a bit how it works and looks. This was recorded on, I think, a Falcon 5 on the SIM slot 2. There was the embedded eSIM, which is always there, and on the first SIM slot I put I think it was the 5-bearer SIM card that works for that. So you can see we just enter the profile. You can set a nickname for the profile, which is actually stored on the on the eSIM. There's some error handling, which I want to demonstrate here. If you put some invalid strings here, I actually get the correct error messages back from LPSC. But if you put the correct things in there, like this, maybe I should also say. So normally you get the eSIM card as a QR code from the operator. Most of the time they also provided in text form also this sort of string, so LPA colon, I think it's always $1 and then the address for the SMTP plus and then this kind of authorization code. If your provider doesn't do this, you can just scan this QR code with a normal phone and just copy the string over to this, and you can install it. There's also one missing feature in the app, it doesn't have a QR code scanner in there. This is mostly because most Linux phone so far doesn't really have either any camera support, or I guess the camera couldn't really or isn't good enough to scan QR codes. So also contributions welcome there. I don't really have a Linux mobile phone with camera yet, unfortunately. But yeah, once you put this in, then LPSC starts downloading it. You get real-time progress from LPSC. What operations is doing, I mean, it's not very pretty because it's just the strings that we get from LPSC. I'm guessing you could just translate this and make it something, but yeah, you get some details there. Then it's downloading and doing some operations, copying some data from the server side into the EUSCC. And then we have the second SIM card here, our second profile. And we can enable this profile. This normally automatically disables the other profile because you can only have one profile enabled without some new things which is slowly coming with SIM cards. Yeah, and you can delete the SIM card if you want to. And like generally an eSIM can store not a fixed number of profiles, but because each profile has basically, I mean, it's basically a file or a bundle of files that you download. And the eSIM has a fixed amount of storage. So if the storage is full, you can't download any more eSIMs. So if they are super tiny, the profiles, you can probably download many of them. I think on my private phone, I have right now about 6 profiles, but I've also heard that for some, maybe for some bigger profiles, you can only download like 4 or something. But yeah, there's also some screenshots which I mostly put here in case the video doesn't work. But yeah, that was it. Thanks for watching or for listening. Are there any questions? Do we have a microphone for the questions? Or I can also repeat it. Okay.
So my first question is, like you said, the component in Android that handles this is entirely closed source.
Mm-hmm.
So if something like a true open source Android was possible, there would be no eSIM.
So the question is about that everything in like all the components for Android are closed source. So if an entirely open source Android, this wouldn't be possible. Easy management. No, because there's actually using the same LPSC backend. There's this project called OpenEUSCC, which is already completely open source. You can't install it as a system app on normal Android because you can't install system apps. But on a rooted app, or for example in Lineage, you could just integrate this into the build and then have easy management working there. I think it is working relatively well. I think it could also have some UI improvements from what I've seen from the screenshots. But yeah, it's also questionable how much beautiful UI you can make for an easy manager. I mean, you're not going to look at this every day, hopefully. But yeah, no, I mean, it shouldn't be anything missing. And from the modem communication side, if you replace the, for example, Qualcomm proprietary modem stack, like below the Android frameworks level, you can also just replace this with an open source variant. So yeah, exactly how it's possible on Linux mobile, you can also do it on Android, which also generally applies to like anything Android. I mean, you can just replace all the proprietary HALs with open source stuff. But just work.
Second question, if I may
Okay.
continue. So I'm downloading the SIM card onto the module in the device. I'm assuming the network would not let me log on with the same SIM twice, but could I have the same eSIM in 2 devices and turn one off and the other one on, and I could still use my...
Yeah, so the question is about downloading the same eSIM to basically multiple devices. I think the SMDP Plus, so the server, would just not give it to you a second time. I think that's the basic thing. And because the communication between the SMDP Plus and the eSIM module is encrypted, like you can't intercept it, and basically you can't make a replay on a second EUSCC. So it is meant to be secure, and unless there's some easy manufacturers that don't follow this and still get GSMA certified, it shouldn't be. Yeah, it should be as secure as possible. Yeah. Or sorry, Ollie, maybe.
Yeah, I have a question from the internet, from DevRTC in the other room. tested whether calls work and with different SIM slots, and maybe repeat it.
You've tested whether calls work in using different SIM slots. I mean, it like once you have enabled it, the SIM card like it works as a regular SIM card. Like if your Linux mobile, if your specific Linux mobile phone supports calls, then yeah, it should just work. What was there was some other part.
Different SIM slots.
Different SIM slots. Yeah, there's like one thing on Linux Mobile which is a problem is that Modem Manager can't really deal with two SIM cards like at the same time. So like dual SIM it can't handle. So yeah, I mean if you remove your primary, like on for example the 4 or 5 devices, which is a SIM slot and one eSIM, you need to remove the physical card and only then enable the eSIM profile. And then you can use the eSIM like as single slot functionality, essentially.
Can you take an eSIM out of one phone and then put it into another phone?
Whether you can take the eSIM out of one phone, put into another, if it's sorted onto the PCB, you can desort it and sort it into a different phone, yes. If it's on a removable eSIM, yes, you can just take the physical SIM card out and put it into a different one. And then basically take it with that because it's still on the EUSCC, put it to a different one. To actually do it non-destructively on a sorted one, there are some protocols which I'm not too familiar with for eSIM transfer. So this is something that Google has also been pushing for. I'm sure you can find something online. But basically, yeah, if you migrate from one phone to the other, like I think even as part of the Android setup wizard, then you get the option to I think only if the network operator supports it, because the network operator needs to do some things with that. It basically will give you, I guess, a new eSIM, but kind of immediately transfer everything, like basically give you a new profile and register the network correctly. And then the old eSIM will be disabled at the same time. So basically, like you would get a new SIM card in the mail, they just give you a new eSIM card immediately. But this is sort of automated. You don't have to actually go to the customer service for that. Another question?
How long did it take you to figure this stuff out?
How long it took me to figure it out? I was definitely watching a bunch of Harald's talk about eSIM, which is quite useful. Like from things, I think under, I guess, Sysmocom and eSIM, you can find a lot of this stuff. I was watching some of these and slowly getting interested also and trying to want to understand it, how it works, and being able to do this on Postmarketers especially. To have the first proof of concept working, I don't know, was a couple of days of, let's say, full time, 30 hours. I mean, it wasn't too bad because, fortunately, Chromium OS already had basically the scaffolding ready for me. So I was just taking that, putting into libqmi, and then, my first attempt was just, trying the libqmi calls, so the QMI, CLI, Open Logical Channel, and then just finding some random APDUs in Stack Overflow and just putting it in there because, I can't just make up random bytes because it's an invalid APDU. But just sending it to it, and then it was actually getting response back, which looked like the example on Stack Overflow, which was amazing. So that was already basically the first part of that. And then it was relatively okay getting this hooked up with this weird Python wrapper script. And the UI building, I mean, it took way too long because I'm not it was basically the first time me building anything with GTK4 and this blueprint thing. And like the documentation and using this with Python is pretty horrible because you need to piece things together from like 5 different sources. But yeah, I'm sure like the UI could be built in probably a day by someone who knows what they're doing.
I might have one more question. That component you took and extended, LSPC?
Yeah, LPAC. Yeah.
Do you know what the original purpose of it was? Was it the same goal to get eSIM working on mobile devices, or do they have different purpose?
It's like the original, let's say, goal of the LPAC open source project.
Yeah.
It is in the namespace of esdk.me, which is a, I think, different eSIM provider. I actually have not really checked too much what they're doing because it's not super obvious from their website, but I think they're also selling some like eSIMs on a plastic card. And so I think just to manage those and put it into maybe IoT products or something could be possible. But yeah, it is. Yeah, I think the developers are Chinese from what I can tell. So there is not super obvious like what they're doing sometimes. But yeah, it's quite a cool product. So and it works. It works. So that's the most amazing part. I think was a question.
What was linked to your GitHub repository when you put the code in?
Link to the my eSIM manager app is actually on Codeberg, codeberg.org/lucavice/ let's say the code name or the package name is called LPA-GTK, so local profile assistant GTK. Wasn't too inventive there, but I didn't want to call it just eSIM manager, so because in the UI it's called just eSIM manager because it's a bit too generic. And I was also thinking that somebody will probably want to make a UI, like a more integrated UI into for Plasma Mobile, for example. So this would then use Qt and Kirigami. But yeah, I also have a blog post on my blog, lucavice.eu, which has all the details and some more things that you can find there. Should have probably put this somewhere. Any other questions? Then thanks for listening. Thanks for coming.